Welcome to Let's Make a Game Platformer, episode 28. In last episode, I've added an ability to define entities that can move within the scene, specifying the transition or translation in this case, using the constant model translate component. Today, I'd like to work a bit more on this component, add a couple of neat features to it, and implement a moving platform using these new features. Okay, so let's start off with doing some refactoring. First of all, I'd like to rename this property to get phase shift. So this is basically how much the cycle or the whole phase of going back and forth is shifted with the current time. And instead of having only cycle time, I'll have 4 different times here. I'll have before time, so this is time how long the entity waits in the base location. Then get move away time, so how long does it take for the entity to move towards this position that is away from the current from the base position. Get away time, so how long the entity waits on that position, and get move back time. This basically allows me to completely define the movement of the entity, both on the starting point and at the destination point, and also how it moves in between. Additional thing I would like to move at the moment, the entities were moving linearly, so the movement was at the same speed all the time. I'd like to introduce maybe I'll group those here. I'd like to introduce an interpolation for both the movements away and back. And interpolation is something that is defined in the libgdx library. I'll link it in the description of this video, and I'll be using it here to give more flexibility of what we want to achieve. I'd like to add a pretty cool effect, I think, to the existing door already. Okay, so let me now, I have to modify the class that uses it, which is the translate system, and we have to modify all the getters here. So first of all, the base time is minus cycle, sorry, not a phase shift. And then we have cycle time is before time plus move away time plus away time plus move back time. So the whole cycle is starting from waiting for the beginning of the movement, then moving away, and waiting at the destination, and then moving back. This is the time of the cycle. So the time in cycle is actually this base time modulus cycle in time, and then rather than half cycle length, we will have a completely different approach to this. So first of all, we will see if cycle in time is less than, maybe I'll extract those as variables here. Before time, move away time, and move back time. So if cycle time is less than before time, that means that we should wait. So A equals 0. So we are at the beginning of the journey. Else, if cycle time is less than before time plus move away time, that means that we are moving away. So, and we are moving away. So in here's when the interpolations come into existence. We have interpolation class, and I've added the interpolation util to the gaming. It allows me to extract interpolation based on name, and the name is specified in the component. So we'll be getting an interpolation that is defined by the component. So in what fashion it should move away, whether it should be this linearly or should it speed up, or many other possibilities. And then we'll be getting this to a value of the cycle time minus before time. So basically this is the start of the moving away, divided by move away time. And we have to make sure that these are floats here, because this is int, I think, oh no, this is int, yes, this is int. So this, if I did this, I will also get a 0 always without them multiplied by 1f, because I'll be having some value integer divided by some value integer that is larger than this one, therefore it will always be 0. But if I multiply it by float first, I'll get a proper float result from this. Okay, then we have if cycle time is less than before time plus move away plus away time. So this means we are waiting at the destination. And otherwise, so we are moving back. So once again, we extract an interpolation. Based on the whatever is specified in the component, and we apply it to 1f once again, because we are moving back. So we are moving from point 1 to point 0 rather than from point 0 to point 1. Therefore, we have to subtract the result from 1f, and interpolation, and we have to apply value of cycle time minus these three, divided by move back time. And once again, we have to make sure that we have float here. Okay, now we can get rid of these, and that should work. It should be time in cycle, not cycle time. And everywhere else as well. So this should be used only here. Yeah, okay. So we have that. So let me now define the model door, sorry, the cycle door here. And rather than cycle time, we have 4 definition of time here. So before time. So let's say it's going to wait for 1 second before it does anything. Then we have move away time. Let's say it's going to be 3 seconds. Then it's going to be away time. So it's going to wait at the destination point for 2 seconds. And then we're going to be move back time, which is going to be 1 second. So we're going to move. So the door will go up slowly for 3 seconds, and then slam down very fast in 1 second. So let's take a look. So if we don't define those, they are assumed to be linear by default. So let's run it and see if that's what's happened. So once again, 1 second, 3 seconds, 2 seconds, 1 second. 1 second, 1, 2, 3, 1, 2, 1. Okay. So this seems to work fine. Okay, so now let's play around with the interpolations here. So what I'd like to do is have interpolation away being linear. I'll do it explicitly here. However, for the interpolation back, I'd like to do, you can imagine port Q is going up, and when it goes down, it slams and bounces a bit. So I'll use bounce out here. So let me bounce out. Run it. So moves up slowly, weights at the top, and then slams with bouncing. Awesome. I like the bounce at the end. Okay, awesome. So I've added pretty good thing here. We can do some awesome stuff here. Now let's work maybe on the platforms themselves. So let me add or maybe call, because we already have platform. Oh no, it's fine. Package platform here. So I will define a new object, which is gonna be moving platform. And I will have a model moving platform. And I will use the same as the grass, the same model as the grass. So top, bottom, sides here. It's going to be 1. Actually, no, it's going to be 2, width of 2. The platform will be width of 2 blocks, so a bit wider. And everything is going to be 1. Okay. So you can imagine that this texture is going to be a bit stretched, but you will just, in other circumstances, you will just add a new texture, which is a bit wider, just to accommodate this. You can do some other stuff as well, but let's go with this for now. As I said, this is not about graphics. This is not this game. This series is about gameplay logic and implementing stuff rather than worrying about making stuff beautiful. Okay, so in here we have model moving platform, and it's gonna be not translated at all. Width 2 and height of 1, and we don't need this. And will be before time is gonna be waiting for 2 seconds, then it's gonna be moving for 3 seconds, waiting for 2 seconds, and moving back for 3, and it's going to be moving linearly, and it's going to be moving 2 blocks to the right, so distance of 2, maybe more than 2, 5. It's going to move for 5 blocks to the right, and back left. Okay, so now I have to add it to this, so I'll modify the existing level here. So rather than having exit portal here, I will have a huge gap here. So it's going to be moving for 5 blocks, and it's going to be width of 2. So gap should be a 3 blocks wide gap. I'm wondering what this is. This is the blocks above. Okay, so it has to be 5 wide block, 7 wide. So at 7 minus 2, 0. Specify stone. 8 and 9, and the exit portal is going to be at 8. And in addition to the cycle door, I will have here a platform which is going to be starting at 1 minus 2, 0, and mode is going to be moving platform. Okay, let's test this. Okay, so we have a platform here, and it's moving over there. It's moving too far. 7, 1. Okay, so this has to be 8, 9, 10, and exit portal has to be at 9, and we have to also modify the max x here. Let's go for 10, and depth is going to be at 15. unfortunately we cannot so at the moment we would have to create a separate prefab for each platform that we want to define in the game. However, this can be fixed, and I'll show it in the next episode how we can do this. Okay, so we have a platform that nicely now moves, because this is way too far, we cannot jump there. However, as you can see here, the platform doesn't move me, even though that's what we probably expect. So now we have to add something to it. So let's imagine how would we go about implementing this, the fact that when this entity moves, it should move whatever is on the and resting on the entity. So we can imagine that on top of this platform, we create a very, very thin layer of hitbox or something like that. And we will, whenever something, or maybe not hitbox, something that we'll be checking if there is any entity that can be moved in this thin layer above the platform. And if there is, we will move it by the same amount of the same distance as the entity is being moved. So let's go with here with platform component, which defines something that basically is gonna be moving whatever is on top of it. For now, it's gonna be just a basic sort of a flag component. We'll create a platform system here. Register the system. I'll register the system, and I will add an index for, so I have to inject. Actually, I don't need to inject. Okay, so I'll create a new component which will contain all the information about the entities that can be moved by a platform, because you can imagine that some entities might be moved by a platform, some entities not. For example, player will be, stars not necessarily, the stars that usually collect. So platform movable component extends component. It's also going to be a flag component, and in the system, whenever, so we have receive event, after component updated, so when location or platform is modified, either of those components, we can figure out how was it moved. So we have old location, and we have new location here. Location minus delta x minus old location get x, and the same for y and z, of course. And then now we have to figure out what's on top of the platform. So we add a new component here to platform, which is going to be translate x. It's going to be very similar to multiple other components we had in the past. So translate y, get width, get height. Okay, so we'll add it here. So our translate x is 0, translate y is 1 because it's above the platform, and the height is 1 of the platform. Width is going to be 2 blocks because that's the width of the platform, and height of this overlay, we'll go to for something very small, like 0.1. So this, as I said, this is the thin layer above the platform. Okay, so we have this here, and now we have to find all the entities that, so we have to iterate through all the entities in the entity system that have a hitbox and have this platform movable component and have a location. And we have to move them if they overlap this one. So we'll inject the entity index manager anyway. Implements lifecycle system. Implement a method. Initialize entity exit manager, add component on platform movable. Second of all, it has to have hitbox. What's the name? Hitbox, rectangle hitbox component, and location component. Movable entities. And we'll iterate through them. Movable entity get component location. Entity location. And movable entity get component rectangle hitbox. And hitbox. I can extract the method later on to the hitbox system, and hitbox should provide me information about this, because if you remember here, hitbox already has the rectangles, already remembers all the rectangles for the hitbox stuff. Actually, maybe I'll here. Yeah, that's a good idea. So let me do it immediately. So I'll have hitbox manager, hitbox overlap manager, and I'll have a method here. Find entities, find overlapped entities with a rectangle 2D, and predicate entity ref. Filter. Okay, so I'll modify this one to, first of all, implement that interface. And second of all, we have to expose it using shared. And in our platform system, we can inject it. It's called hitbox overlap manager. So actually, we don't need this. And instead, if it moves, first of all, let's check if it moved at all. So either of them is not 0. And instead of that, we'll construct the rectangle for this, for the above the block rectangle. Platform rectangle. And it's gonna be at the old position. So old location get X plus platform get translate X. Old location get Y plus platform get translate y. And the reason why we are using the all location is that you're only, so if platform suddenly moves under an entity and the entity wasn't on top of it before, it should not move it at that point, only when it started the movement when the entity was on it. And finally, platform get width and platform get height. So this is the rectangle that's for the old position of the platform. And now we will use the hitbox overlap manager, find those that overlap the rectangle, and we have an entity ref filter specifying that the entity ref has component platform movable component. And if they do, we'll iterate through them. Entity to move, and we move it by the distance. So entity to move, get component, location component. Entity location set x, entity location get x plus delta x, and the same for y and z. And we have to save the entity. Okay, so we have this, and now all we have to do is just overlap, just write a method for this interface. So let me do it here. And we'll get through. So first of all, I create a list. Let's call it result. We'll iterate through all hitbox entities. We'll get the shape of it. If shape intersects rectangle, then we add the entity to the result, and finally add only if the filter matches it. If it matches and the entity overlaps, then we add it to the result, and finally return the result. Okay, so now what we have to do is just specify that player actually can platform movable component. That the player can actually be moved by platforms. And let me run it and see if it worked. Okay, I think we know what the problem is. The problem is I didn't specify that this system exists only in gameplay module, gameplay profile. So the gameplay context. Okay, let's run again. Okay, so let's see. Oh, now we have to wait for it to come back. You could jump on it, but it's much more fun when you can walk on it and wait. Awesome. Okay, that's it for this episode. Make sure to like it and subscribe to my channel. You can also follow me on Twitter, link is in the description. Thanks for watching. Bye.